All right, now this assignment is going to have us practicing some more difficult applications. And as always with math, there are usually a few different ways when a calculator is allowed to solve some of these problems. So I will show you how to solve some of these algebraically as well as graphically. All right. A plane is flying within sight of the Gateway Arch in St. Louis, Missouri at an elevation of 35,000 feet. Elevation is the vertical distance from the plane to the ground. The pilot would like to estimate her distance from the Gateway Arch. She finds that the angle of depression, or elevation, to a point on the ground below the arch is 22 degrees. And there are two questions. What is the distance between the plane and the arch? And what is the distance between a point on the ground directly below the plane and the arch? So there's a lot of words here. And a lot of times the hardest thing is just to figure out, like, what is this picture? So just start with a right triangle. There's a plane up here, right? You can either draw one or just use words. And the arch is down, a point below the arch is down here. All right, so what do we know? We know that the elevation of the plane is 35,000. So that's this leg right here, 35,000. Remember, in Desmos, you can't type commas, so maybe I'll try not writing commas either. 35,000 feet. The pilot would like to estimate her distance from the Gateway Arch. She finds that the angle of depression to a point on the ground is 22 degrees. Remember, the angle of depression is not right here. It's never against the vertical leg. It's actually out here. This is 22 degrees. But we always want to put it in our triangle. So that's why I said depression, really read that as elevation. If you're looking from the plane to the arch, you'd be looking at the same angle from the arch to the plane. So this is 22 degrees here. All right, so what about part A? So part A wants the distance between the plane and the arch. Well, the distance from the plane to the arch is the hypotenuse. So let's just call that A. So for part A, I have opposite, and I'm trying to find hypotenuse. That means you should be using a sine function. So sine of 22 degrees equals 35,000 over, I'm just going to call it A, just since this is part A. All right, so that means that, how do I solve for A? I want to multiply A to this side. So it would be like A times sine of 22 equals 35,000. And then I need to divide by sine of 22. I wouldn't suggest solving this by graphing, although you probably could. But the numbers might be kind of large here. These are big numbers. So instead of solving by graphing for something like this, I think it's best just to do the algebra. It's also important to know that this is the algebra. It's like 2 steps. All right, we need to type this in and round to 3 places. Remember, in Desmos, the mode matters. So if you're not sure what mode you're in, you click the little wrench up here. And right now mine's in radians, so I need to change that to degrees because the angle I'm working with is in degrees. And I'm trying to get this. Come on. There we go. And so then I'm just going to type this in. So that was 35,000 divided by the sine of 22 degrees. So I get that A is 93,431.351, and that's measured in feet because the other distance was in feet. So this is the distance from the plane to the arch, the plane in the sky to the arch on the ground. Part B was asking, what is the distance between a point on the ground directly below the plane? So right here, this point on the ground, and the arch. Let's call that B. So they want the adjacent leg. Now, even though you just found the hypotenuse, you rounded it. So you don't want to use a rounded number. Also, what if you did the math wrong on that? Even if you use your unrounded fraction here, if you messed up, then it's not going to give you the right answer. So go back to the given information. Work with opposite and adjacent. So for part B, I need a tangent function. Tangent of 22 degrees equals opposite 35,000 over adjacent, which is B. I'm going to do the same math here where I multiply the B to this side. And it's B times, I'll show it one more time. B times tangent of 22 degrees equals 35,000. So B equals 35,000 divided by tangent of 22. I would be perfectly happy with you just going from here to here, but I'm just showing you what's happening in case you get confused on that. And really, all I have to do is tweak this answer a little bit. Let's just erase the sign and make it tangent. Still in degree mode, so this is still the correct answer. When we have a test or a quiz, I will not have the problems like degree radian. There will be a section where you're in degree mode. There will be a section where you switch to radian mode, and I'll remind you in the directions. 86,628.040 feet. Always label your answers, and always round to 3 places. Okay, let's look at the next problem. 47. This picture is hard to imagine. I think we would probably be given this picture if it were an AP problem. A laser beam is to be directed toward the center of the moon, but the beam strays 0.5 degrees from its intended path. So let's just think about that. Here we are on the Earth. So we have this laser that's like, sitting on the Earth. And we're supposed to be beaming it directly to the center of the moon. So here's my moon. It's supposed to be going here, center. That's supposed to be the center of the moon. It strays a half degree. I don't really know what a half degree is, like what it would look like to scale, but that's the way the laser is actually pointing. So is it going to hit the center of the moon? No. I don't know if it's actually missing the moon or not. I just drew it this way. So actually we hit somewhere, let's just say we hit somewhere here. And so that would mean that you have this, you could extend that out to like being perpendicular to the like center of the moon there so that you get this right triangle. Okay, so all I have so far is that this is a half degree angle. Part A says, how far has the beam diverged, which just means strayed from its intended like path. What is this distance? When it reaches the moon. The distance from the Earth to the moon is 240,000 miles. All right, so what we're looking at is actually this. The distance from the Earth to the moon is 240,000 miles. So maybe instead of drawing my right triangle that far, I should have gone this way. If we're only measuring to the moon, we're saying, all right, by the time we get to the moon right here, how far off the path is it? So how far away? It should be right here when we hit the moon, but how far up is it actually? Let's call that y. It's a vertical distance. I could use a as well because it's part A, whatever. All right, well, I have everything I need. I have one side length and an angle. That's all I need to find another side length. And I'm looking for the opposite, and I have the adjacent. So that means I should be, for part A, setting up a tangent equation. So the tangent of the angle, 0.5 degrees, equals the opposite y over the adjacent 240,000. To solve for y, I need to multiply 240,000 over to the other side. And then I will type this in to see what our answer is in approximation. So 240,000 times the tangent of 0.5. Remember, I'm still in degree mode. Okay, so my answer for y is 2,094.448. 2,094.448. We are measured in miles because that's what the 240,000 was measured in. That's my answer for A. So that's how far from where we should be hitting the moon to where we actually are. And then part B says the radius of the moon is about 1,000 miles. Will the beam strike the moon? So remember earlier how I said, yeah, I don't know if I should be drawing this vertical leg to like hit the moon or not. Well, this radius is 1,000 miles. And we just discovered that y is 2,000 something, 2,094. So no, this is going to be higher than the moon. It's going to like completely overshoot and miss the moon. So for part B, I'm going to say no, because how about we say this in terms of the question before? How far has it diverged? The beam diverged, I'm just going to say more than 1,000 miles from the center of the moon. Because that matters. We were we were pointing at the center and we were off by 2094. If we were pointing at like the bottom of the moon and then we were only off by 2094, we would hit the moon. We were pointing at the center, so we're going to miss. All right, 48. From the top of a 200-foot lighthouse, the angle of depression or elevation to a ship in the ocean is 23 degrees. How far is the ship from the base of the lighthouse? Okay, where do I start? I start with a right triangle drawing. It's a 200-foot lighthouse. That's the height of the lighthouse. So this is my lighthouse, the top of it. And there's the ship in the ocean. There's an angle of depression of 23 degrees. So remember, the angle of depression from the lighthouse down to the ship is 23 degrees. That's the same as the angle of elevation. Because the amount you have to turn your head to look down to the ship is the same amount you have to look up to the lighthouse. How far is the ship from the base of the lighthouse? So here's the base or bottom of the lighthouse. So let's just put an X right there. That's our missing distance. We have opposite and adjacent. I think I said this in the notes. We're going to use tangent a lot because it's usually pretty easy to measure horizontal and vertical distances, or to at least have that information. All right, so using tangent, the tangent of 23 degrees equals 200 over x. Remember, to solve for this, you multiply x over here, and then you're going to turn around and divide the tangent to the other side. So it will be 200 divided by the tangent of 23 degrees. And let's see what that comes out to. So I'm getting 471.170. What's it measured in? Feet. All right. For the next question, classic ladder problem. We see these all the time in trig. A 20-foot ladder leans against a building so that the angle between the ground and the ladder is 72 degrees. How high does the ladder reach on the building? Where do I start? With a right triangle. Now this is the building. How high does the ladder reach? So how high is this point? Let's call that y. I like doing vertical distances or y and horizontal or x. The angle between the ground and the ladder, this is the ladder, by the way, leaning against it. So this angle here is 72 degrees. And the 20-foot ladder, that is the length of this ladder. So that's actually the hypotenuse. All right, so we have opposite and hypotenuse. So that means we need to use the sine function. The sine of 72 degrees equals the opposite y over the hypotenuse 20. To solve for y, you're going to multiply the 20 over to the other side. And we plug it in and see what it comes out to. Sine of 72 is 19.021 feet is my approximation for y. All right, another leaning ladder. A 20-foot ladder is leaning against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle of elevation of the ladder? And how high does the ladder reach in the building? So we have two things to find. First, draw your triangle again. Just like the previous problem, we have a 20-foot ladder, so that's this, hypotenuse. The base of the ladder, bottom of the ladder, is 6 feet from the bottom base of the building, so that's 6. What is the angle of elevation, which is always from the ground up to the hypotenuse? Let's make that theta. And how high does the ladder reach? Let's make that y. So start with theta. I have adjacent and hypotenuse. Now, I could reduce those, but I don't want to because I don't want to accidentally give the reduced answer for y. So I'm using a calculator, so it doesn't matter. So this one is cosine of theta equals 6 over 20. And remember, to find theta, you inverse cosine both sides. So you get the inverse cosine of 6 over 20. Just like we said in the previous chapter, we're going to natural log both sides to get rid of the base e. We can inverse cosine both sides. All right, so, and I'm in degree mode, so this will give me an answer in degrees. The inverse cosine of 6 over 20, I'm not worried about reducing there, is 72.542 degrees, and that's my approximation for theta. Okay, how high up the wall? Now, don't use the angle that you have. You don't want to use like tangent or sine to figure out your y value. Just use Pythagorean theorem. So for this one, it's just to figure out y, it's just 6 squared plus y squared equals 20 squared. Okay, so y squared equals 20 squared minus 6 squared. You're still allowed to use a calculator here, might as well. So y will be the square root, the square root of 20 squared minus 6 squared. And that is approximately 19.079 feet is our answer for y. All right, what's the next problem? So far, all of these have been like single triangle problems, which is kind of nice. We'll get a bit more challenging once we hit 54, because we'll have 2 triangles to look at. Angle of the sun. A 96-foot tree casts a shadow that is 120 feet long. What is the angle of elevation of the sun? So with the shadow problems, it's easy to accidentally put the length of the shadow in the wrong spot. So draw your right triangle again. Yes, I do keep drawing just the same right triangle in the same orientation. The tree would be the vertical length. Here's my tree. So 96 feet. The shadow that it's casting would not be the hypotenuse. The shadow that it's casting, think about where you see shadows. You see them on the ground. So that's the ground, the length of the horizontal leg. The sun is up here somewhere, right? Casting this shadow, which is causing this shadow to be on the ground here. What is the angle of elevation to the sun? So again, we have opposite and adjacent. So I'm going to say the tangent of the angle theta is equal to 96 over 120. How do I solve for theta? I inverse tangent both sides. So it's whatever the inverse tangent of 96 over 120 is. All right, so I like having a clear screen when I can. So inverse tangent of 96 over 120. 38.660. Degrees. Not sure what's going on with my pen here. Stick it into charge for a second. All right, number 52. Height of a tower. A 600-foot guy wire, I'll explain that in a minute, is attached to the top of a communications tower. If the wire makes an angle of 65 degrees with the ground, how tall is the communication tower? So right triangle. You might have seen these on like I don't know if they're telephone poles or power lines or whatever, but it's just what a guy wire is, just this wire that you attach to something to keep it like steady, basically. Like it's not going to be blowing around in the wind or whatever. So guy wire is 600 feet. There. Communications tower, we're assuming is vertical. We don't know how tall it is, so let's call that Y. And the wire makes an angle with the ground, also known as an angle of elevation, 65 degrees. So we have opposite and hypotenuse. So the sine of 65 degrees will equal y over 600. To solve for y in the numerator, we multiply the 600 to the left side. And we go from there. 600 times the sine of 65 is 543.785 feet. Okay, so now we have to really read through these a couple of times maybe to get the picture here. Oh no, sorry. One more normal one. Elevation of a kite. A man is lying on a beach flying a kite. Weird, but okay. He holds the end of the kite string at ground level and estimates the angle of elevation of the kite to be 50 degrees. Some of these scenarios just make me kind of laugh. If the string is 450 feet long, how high is the kite above the ground? All right, so right triangle. Somehow this guy is laying on the ground flying a kite. Maybe that's a thing you can do. I thought you had to run to get him going, but whatever. The angle of elevation is 50 degrees. That's always down here by the ground. The kite would be flying diagonally, right? It's not going to be flying straight up from him. So the string is the hypotenuse, 450. And the question is, how high is the kite above the ground? So the kite's way up here, so that would be this distance here. Opposite and hypotenuse means we need to set up the sine of 50 degrees equals y over 450. And we'll multiply by 450 to get y. So that's 344 point. This would round to 720, and we're talking feet. All right. Oh, wait. No, yeah, that's fine. Sorry. Okay. This problem, I meant to erase this here. I don't want to give anything away, has two right triangles in it. Notice the big triangle is not a right triangle, but there are two right triangles in here. We have this one, which has an 18-degree angle, and this one, which has a little 14-degree angle. And X is a leg in both of the rectangles, or triangles. A woman standing on a hill sees a flagpole that she knows is 60 feet tall. This whole thing is 60 feet tall. The angle of depression to the bottom of the pole is 14 degrees. The angle of elevation to the top of the pole is 18 degrees. Find her distance x from the pole. I always get this question of like, shouldn't it be proportional? Like, whatever fraction 14 out of, what would this add up to be? 32? Isn't 14 out of 32, like that fraction would be the same fraction of 60? It doesn't work out. And I've looked into this before. It's something about sectors, vertical distances. If the flagpole were curved so that these were radii of a circle, that would be true. But it's not just going to be the same fraction that this angle is, that 14 is out of 32. That's not going to correspond to that same fraction of the 60. Okay, so then what do? We don't know how this is split up. It's not going to be 30-30, I can tell you that. Let's just say this section is y feet, and we know this whole thing is 60. So however much this takes up, this is the rest of the 60, which would be like 60 minus y, right? So that if this is 40, this is 20. Or if this is 50, this is 10, etc. Find her distance x from the pole. So the thing about this is that we have two unknowns, but we also have x and y, and we have two triangles to set up. So set up the top triangle first. Y is opposite, x is adjacent. So I can say I have the tangent of 18 degrees. That would equal y over x. That's kind of all I can do with that right now. And then go to the other triangle, and you can say I also have opposite and adjacent. So the tangent of 14 degrees would equal opposite, which is 60 minus y, over x. We want to find x, figure out what x is. So let's get x in both scenarios out of the denominator. Okay, so that would be x times tangent of 18 degrees. That would equal y. and x times tangent of 14 degrees, that would equal 60 minus y. And now here I have some options because I just said, we can do things algebraically or we can do things graphically. I want to solve for x. So in both equations, I would like to get x by itself. So let's do that. X equals y divided by the tangent of 18. And x equals 60 minus y divided by the tangent of 14. Now, if both of these equations are equal to each other, then we can say y over the tangent of 18 would have to equal 60 minus y over the tangent of 14. Now, I can keep going and solving algebraically, but I kind of like to pause and see, can I just solve this graphically? Because if I solve this graphically, I'll get an answer for y, and I can go plug it back in for x. And I'll show you another way where I always do this. I want to solve for x, so I shouldn't get x by itself. I should get y by itself. Actually, let me do that first. Sorry. Let's go back. This way would have been just fine. But, if I want to solve for x and these equations both have x in them, then I should isolate y. And that will make the answer I get for x will be the final answer. So if I want to solve for x, I want to, let's say this, keep x, get y alone. Okay, sorry for that confusion. So this one's already set. This one needs a little work. Now I would just add y to this side. So it would be like y plus x tangent of 14 equals 60. And then I would just subtract the x. So y equals 60 minus x tangent of 14 degrees. You could also subtract 60 and divide the whole thing by -1, but I think this is easier. Okay, so I have these two equations that are equal to y. That means we can set them equal to each other. X times the tangent of 18 degrees has to equal 60 minus x times the tangent of 14 degrees. Again, I could do some algebra, but let's just see if we can solve by graphing. Let's look at what these two are equal to. So now if I just type the x's, I'm not sure that it will give me a good answer in Desmos. So let's go back to their y equations. So y equals x times tangent of 18. And y equals 60 minus x times tangent of 14. And, t equals, I meant y equals. And I just want to know where these cross. What is the x value where these cross? 104.485. And what would the label be on that? Feet. That's what x equals. How do I know that's x? Because remember, I'm finding the x coordinate in their intersection point. What if I would have gone back and solved it for x like I did before? Let's look at that. It was x equals y divided by the tangent of 18. That was this equation. And then this other equation was x equals 60 minus y divided by the tangent of 14. And see how those two cross at the same place? And then you're just like, all right, well, what's the x value here? What if I wanted to solve algebraically? Like, what if I can't get the intersection to show up nicely in my Desmos? You do need to know how to do it algebraically for that reason. Really, kind of just for that reason. Well, we solved problems like this in our exponential and logarithm unit. So go back to this equation here. If you have two terms that have x's in them, you want to get them on the same side. So add x times tangent of 14. Anything that doesn't have an x on it stays on the opposite side of the equation. This allows you to factor out an x. And then you could divide by the parentheses. Let's see if this gives me the same answer. I am not requiring you to solve algebraically, but again, it's just a very good skill to have It's a skill that we've used before. Plus tangent of 14. Yeah, we get the same answer, right? That was what we had, 104.485. So it's sort of like use your preferred method. I prefer to solve by graphing. It's so much faster. But sometimes we know that when the answer is really large or just we had a typo or something, it can be hard to get that intersection point to show up. So you just have to be careful. All right, let's look at this one. Seems like a similar scenario, but maybe we have a different side length. So a water tower is located 325 feet from a building. See the figure. So they've given that distance here, but that's this length from here to here. So 325. I'm going to put it in the picture. From a window in the building, an observer notes that the angle of elevation to the top of the tower is 39. That's marked in for us. Angle of depression to the bottom of the tower is 25. Also marked in for us. How tall is the tower? How high is the window? So the height of the tower would be this whole thing. If I find these two vertical distances, I can add them together, and that's the height of the tower. So let's call the first one X and the second one Y. And both of those are opposite, and the 325 is adjacent. How tall is the window? How tall is the tower is X plus Y. How high is the window? Well, the window's here, and from the ground, that's just like my Y, the way I labeled it in my picture. So let's set this one up as well. The tangent of 39 degrees equals X over 325. Actually, this one I can solve for X right away, can't I? So X is 325 times the tangent of 39 degrees. And before I type that in, let's see what Y is. So Y would be the tangent of 25 degrees equals Y over 325. So Y is also 325 times tangent of 25 degrees. And I don't need to find these separately and round them, then add them together. How tall is the tower? So tower height equals X plus Y. And I can just write that. I've defined X and Y. And that is approximately what? Let's just type the whole thing in and see what it comes out to. So get all these out of here. All right. So that was 325 times the tangent of 39 plus 325 times the tangent of, was it 25? Yep. 25. And the answer comes out to 331.700 feet tall. There's the second question, how high is the window? The window height is just equal to Y. And if I'm just careful about which one is Y here, I'm just going to delete the first part. Y was 325 tangent to 25, so there's Y. So it's 151.549 would round to 550. All right, so that one was not as tricky as the previous one. 56, determining a distance. An airplane is flying at an elevation of 5,150 feet, directly above a straight highway. Two motorists are driving cars on the highway on opposite sides of the plane. That means this. Normally we draw a right triangle, right? We're like, okay, the elevation of the plane is the vertical distance, 5,150. We're directly above the straight highway, so that means we have a right triangle. The cars are on opposite sides. So let's say this is car 1 here, opposite sides of the plane. The plane is up here. That means that car 2 is like over here somewhere. And I have no idea which one should be farther away, whatever. I'm not too worried about the scale of that drawing. The angle of depression to one car is 35 and to the other is 52. Remember, angles of depression are out here. The way I drew it, I'm going to put the 35 here and the 52 here. Remember, this really is just an angle of elevation, though. So 35 and 52. You're not given the angles from the vertical side. It's always from the horizontal. How far apart are the cars? Well, I don't know this leg. I'm going to call it X. And I don't know this leg. I'm going to call it Y. The distance between the cars is X plus Y. I have an angle and I have a side opposite. And in both cases, the X and the Y are adjacent to those angles of elevation. So this should just be like the previous one, I think, or similar to it, I should say. So tangent of 35 degrees would equal 5,150 over X. And the tangent of 52 degrees would equal 5,150 over Y. I want to get X plus Y, so let's solve each of these for X and Y. Remember, you multiply the X over to this side, and then you're going to divide the tangent of 35 to the other side. So X will equal 5,150 divided by the tangent of 35. Y will equal 5,150 divided by the tangent of 52. And the distance between the cars is X plus Y. That's not bad. We can type that in. So 5,150 divided by tangent of 35 plus 5,150 divided by tangent of 52. All right, so how far apart are the cars? X plus Y is 11,378.583, and we've been measuring in feet. Now, 57. If both cars in exercise 56 are on one side of the plane, and if the angle of depression to one car is 38 and the other is 52, I don't know why we had to make that difference, how far apart are the cars? So the picture has slightly changed. Imagine that you're swinging this car 2 over to this side. So let's draw that picture. Okay, so we still have the same elevation, which was 5,150. The plane's right here. Now the cars are on the same side. So car 1 is still out here. They did change this to 38 degrees for no good reason, really. And then instead of the other car being over here, let's put him right here, car 2. And when we say we have an angle of elevation of 52 degrees, that would be from the horizontal to that hypotenuse. What's the distance between the two cars? So this little distance from the bottom of the base of the plane there to car 2, let's call that X. And then I'm not going to put a Y right here. I'm going to put, we've got this big right triangle out here. The distance from car 1 to the spot below the plane, that's going to be Y. So the distance between them will be whatever Y is minus whatever X is. That's the distance between the two cars. That's what we want to find. So how far apart are the cars? It'll be whatever Y minus X is. So let's set up our two equations again. Let's start with Y. So Y is the big triangle here. So ignore the 52. It's just this outer part. So the tangent of 38 degrees should equal 5,150 divided by Y. And Y would then come out to 5,150 divided by the tangent of 38. And then what about X? So now ignore the 38 part. We're just looking at this small right triangle here. The tangent of 52 degrees is equal to 5,150 divided by X. Solve that for X. X is 5,150 divided by tangent of 52. And then how far apart are the cars? Y minus X. If you accidentally subtract backwards, hopefully you will catch that your negative answer really just should have been positive. So there's that. Oh, I should have kept that. So I just had to, actually I could do Control Z. And I just need to make a slight change, right? 5,150 divided by tangent of 38 minus 5,150 divided by tangent of 52. Or type it out again. It's not that hard. So how far apart are the cars? I got 2,568.078, still measuring in feet. All right. Let's see what the next problem says. A hot air balloon is floating above a straight road, much like our plane before. To estimate their height above the ground, the balloonists simultaneously measure the angle of depression to two consecutive mileposts on the road on the same side of the balloon. So that is a picture like this. So let's draw that triangle and then we'll put some labels into it. So we have this big right triangle. The balloon is floating up here. We have milepost 1 and milepost 2. There are angles of depression that go out to those. Remember, that just corresponds to angles of elevation. So let's not even bother with the depression part. The angles of depression are found to be 20 and 22. Now, 20 would have to be, if you're not looking up as high, you're farther out, right? This angle is smaller than this angle. So put 20 degrees here and 22 here. How high is the balloon? Let's call that Y. We don't know about this horizontal distance, but there is a number in here. It's just sort of hidden. These are mile markers. Mile markers are marking every mile along the road. So, how far apart are these 2 points? These 2 points are 1 mile apart. How far is mile 2, the second mile marker, from this point here? I don't know. Let's put an X there. And then what does that make the bottom leg that we need for the big triangle? It makes it 1 plus x, or x plus 1. Now that you have your triangle drawn out, it's the same as this scenario. It's just that I didn't know the big distance here and I didn't know this length here. All right, so let's start with a big triangle. So ignore the 22. You just have this big triangle on the outside. So it would be the tangent of 20 degrees equals opposite y over adjacent, which is x plus 1. And I'm not going to solve that yet. I'm going to put a pin in that. And then what's the other smaller triangle? It's the tangent of 22 equals y over x. And it really doesn't matter. Actually, you know what? Let's just try something right now. Let's just type this in as it is. I will rearrange it so I can solve algebraically if I need to, but let's just see, once you get this equation set up, let's just see if we can find the point of intersection. Tangent of 20 equals y over x plus 1, and tangent of 22 equals y over x. The point of intersection between these two graphs should be my xy coordinate that works, right? So let's take a look here. Somewhere in here, I'm going to click somewhere near there, and a gray point shows up. And what do I get for my x and y? Yeah, so, and which one do we want? Let's see. So the coordinate that I get is this xy. How high is the balloon? What is that in your picture? You want y. It's a good idea in the problem to note what you want. So how high is the balloon is y, according to your picture. So you get your picture drawn, and then you go back and remind yourself what you're trying to find. So the point of intersection is 3.672. So I'm going to write this over here. So how about I do this? By Desmos, y is about equal to 3.671. What are we measuring in? The 1 represents miles, so those are miles. Okay, what if you get mixed up and you're not quite sure, and so you start trying to solve this thing? Okay, so then what I would do is multiply the x's over, right? So it'd be x plus 1 times tangent of 20. That equals y. And x times tangent of 22 equals y. It's important to have the x plus 1 in parentheses or distribute the 20 through. What if we solve by graphing there? Because we could say, okay, that means that they're both equal to y. Let's see where they cross. So that should work out as well, right? So let's see if that gives us the same answer. So I could say x plus 1 times tangent of 20 equals y. Do I even need the equals y? I guess I don't need the equals y. I'll put it just in case. And x tangent of 22 equals y. And I get the same points, right? Y is this. All right, what if you're trying to solve algebraically? Well, if you're trying to solve algebraically, then you've got some more work to do here. So maybe you are having trouble finding that point of intersection. Or maybe it's a non-calculator problem and we're looking for some multiple choice answer or something. So if I'm trying to solve for y, I would want to leave y in the equation and get x by itself. So I could say, all right, x plus 1 equals y divided by tangent of 20. X equals y divided by tangent of 20 minus 1. And then over here I could say x equals y divided by tangent, divided by tangent of 22. And if these equations are both equal to x, I can set them equal to each other. Again, I could solve by graphing from here. Or maybe I'm just trying to figure out like what my answer is as an exact answer. So get your y's together. So I'm going to subtract y over tangent of 22 to the side, and I'm going to add 1 to the other side. Factor out a y. Divide by the parentheses. Remember, this is not just, you can't just say, oh yeah, flip that and make it tangent of 20 plus tangent of 22. That is not how complex fractions work. Well, let's see if I get the same answer if I type this thing in. You are not required, by the way, to type this whole thing in. I'm just showing you, some of the math behind this. It's good to know several ways. It's got the same answer. It's good to know several ways to solve a problem so that you can, if one way isn't working for you, you can still get to the answer. I'm going to show you one more. I know this is obnoxious, but I'm going to show you one more. What if back here you said, what if back here you went this route? X times tangent of 20 plus tangent of 20. So I distributed the tangent through, and then equals x times tangent of 22. And then I say, okay, same idea. Get your x's together. X times tangent of 20 minus x times tangent of 22 equals, subtract that one over, negative tangent of 20. Factor an x out. Divide by the parentheses. The thing about this one, though, is you're going to see when I type this in, I don't get the 3.671 answer that I should get. So we'll talk about that in a second. Let me type this in, though. So that was negative tangent 20 divided by tangent of 20 minus tangent of 22. I'm not getting 3.671 like I'm supposed to. I'm getting 9.086. Remember, this is the answer for x, and I want the answer for y. But remember, there's a relationship between x and y. You have a couple of them, actually. X plus 1 times tangent of 20 equals y, or x times tangent of 22 equals y. So if I take this answer and I multiply it by tangent of 22, I get the answer I'm supposed to have, because y is equal to x, which was this, times tangent of 22. If you take the numerical answer unrounded, times tangent of 22, same thing. I prefer you just way back here solve by graphing, please. But if that's not working for you for whatever reason, then you have alternative ways to do things. Okay, height of a mountain. We have 2 more problems here, so let's see. To estimate the height of a mountain above a level plain, the angle of elevation to the top of the mountain is measured to be 32. 1,000 feet closer, this is like the mile marker, it's found that the angle of elevation is 35. Estimate the height of the mountain. Give yourself a right triangle. So we don't know the height of the mountain, we'll call it y. We're sitting out here. Our first look is 32 degrees. Then we get 1,000 feet closer. And now the angle of elevation is a bit steeper. It's 35. We don't know how far we are, the 35-degree angle. We don't know how far that is from the base of the mountain. We know that this whole distance is x plus 1,000. Just like the mile marker problem, just different numbers. So start off the same way. The tangent of 32 degrees is equal to y over x plus 1,000. The tangent of 35 degrees is equal to y over x. Stop right here and solve with Desmos. Which number do we want? The height of the mountain is y. I am going to do this algebraically as well, of course, but if I'm on a quiz or a test and I'm allowed, or the AP exam, whatever, and I'm allowed to use a calculator, I am solving by graphing. So how do we do that again? We type in both equations separately. The tangent of 32 degrees equals y over x plus 1,000. And the tangent of 35 degrees equals y over x. We're talking about the height of a mountain, right? It's going to be a fairly big number. Right now I only see one graph. I'm going to have to zoom out quite a bit. There's the other graph. Okay, here we go. Click somewhere near. Again, pay attention to which answer you want. We want the height of the mountain, which is the y coordinate. So this mountain is 5,807.655 feet. What if I try doing things algebraically? Well, I want y, so I'm going to solve for x and see what happens. So it would be x plus 1,000 times the tangent of 32 equals y, and x times the tangent of 35 equals y. I want to get rid of the x. I want to solve both for x so I can keep y in the equation. So I'm going to say x plus 1,000 equals y divided by the tangent of 32. That means that x equals y divided by the tangent of 32 minus 1,000. Over here, x is just y divided by the tangent of 35. Because both of these equations are equal to x, I can set the equations equal to each other. So y over the tangent of 32 degrees minus 1,000 has to equal y divided by the tangent of 35. I could stop here and solve by graphing. I'll show you that. So if I do that one, that would be y over tangent of 32 minus 1,000 equals y over tangent of 35. And what is this y value that I'm getting? See how all the way across it's 5,807.655. So that was our answer that we got here. Okay. What if I don't want to solve by graphing? I'm in algebraic mode, so I'm going to keep going. So then I would say get your y's on the same side. So I'm going to subtract y over tangent of 35. I'm going to add 1,000 to the right side. Factor out a y. That makes this 1 over tangent of 32 minus 1 over tangent of 35 equals 1,000. And divide by the parentheses. And then it comes down to carefully typing your answer in. But I should get the same 5,000 number that I had before. So 1,000 divided by 1 over tangent 32 minus 1 over tangent 35. Yep, same answer. If I solved for x in the other ones, if I got an answer for x, I would have to say whatever my answer for x was times tangent of 35, that would be my answer for y. This is probably a super long video already, so I'm just going to go on to the next one. All right, number 60. They gave us a picture. That's nice. To measure the height of the cloud cover at an airport, a worker shines a spotlight upward at an angle of 75 degrees from the horizontal. An observer 600 meters away measures the angle of elevation to the spot of the light to be 45 degrees. Find H, the height of the cloud cover. This is another one where we don't know how the 600 is split up. So let's call one of these distances x and one of these 600 minus x. But actually, we can make this a lot faster if we want to. We can still solve with two variables like we were doing before. But also, if this is 45 and this is 90, this is 45. So what do we know about x and h? We know that they're actually equal to each other. And then that's kind of cool because instead of 600 minus x, this is 600 minus h. So we can actually make it a shorter problem instead of having two variables. So we could say that the tangent of 45 degrees is equal to h over h, which is really just 1, right? So we have tangent of 45 degrees is equal to 1. And then over here, we have the tangent of 75 degrees is equal to h over 600 minus h. Now, this is the one we can actually work with because this one kind of gives us a dead end, right? Tangent of 45 degrees equals 1. There's nothing to solve there. Here, we do have something to solve. I could just type this in over here on Desmos, or I could solve for h. I'll do both. Let's type in over here this equation. So tangent of 75 degrees, oh, I don't need to type in degrees, what am I doing? Equals, I don't know if it'll like h over 600 minus h. It probably doesn't know about that because I don't have a, what do I want to say? I don't have like an h axis. So h represents the vertical height, right? So let's turn that into y. That's another one where if you're like, wait, what's happening? I don't know what's going on. You can say, well, and what is this coming out to? Find this point of intersection here. I really can't find the point of intersection. So here's one where my solving by graphing is kind of going wrong. So what do? I solve algebraically. It's a good example of like, what's happening here? There's probably some way I can do this, but okay, instead of that, I think this is crashing again on me. There we go. Instead of doing that, let's solve algebraically. So how do we do that? We multiply 600 minus h with parentheses over to this side. Now I want to solve for h, so I do want to distribute the tangent through. So 600 times tangent of 75 degrees minus h times tangent of 75 degrees equals h. Get the h's on the same side, so I'm going to keep 600 tangent of 75 over here. I'm going to add h tangent of 75 over to the right side. That allows me to factor an h out of the right side. So 600 tangent of 75 degrees equals h times 1 plus tangent of 75. And let's divide by 1 plus tangent of 75 degrees. Now, this is good because now I have something that I can just type in and I don't have to solve by graphing. It'll just tell me what the number is. 600 times the tangent of 75 divided by 1 plus the tangent of 75. There we go. So 473.205. I wish I would have left that line up. It looked like it was around that value, but I wouldn't have gotten that decimal the way that I had it graphed. All right, so my answer for H is 473.205. And what is this measured in? This time we were talking meters. So meters is our approximate value for H. Okay, so that last problem is an example of a scenario where you need to be able to solve algebraically because sometimes the graphing, the way I typed it in, probably wasn't the best way. And so then I got to a place where I couldn't see what the numerical answer was. All right, those were a lot of problems. We worked on them for 2 days in class and a little bit outside of class. So if you have any questions or if you need more practice on these, please just come into office hours or flex and let me know.